The parsing algorithm can be represented using the pursuit code as follows. In this algorithm, the stack represents the pass stack that holds the symbol being processed during the parsing process. And the algorithm continues until if you can this code you can see this code not empty stack, that means the algorithm continues until the stack becomes empty, indicating the completion of the parsing. That is the one case. In that case, algorithm continues until the stack becomes empty, that indicates the pass is complete. The other case, that means the algorithm continues until the algorithm produces an error. That is this case. In this case, algorithm produces an error. The algorithm handles two scenarios. What are those two scenarios? Two scenarios are when the symbol at the top of the stack is a terminal and when the symbol at the top of the stack is a non-terminal. These two blocks in this code, in this sentence, in this line, it checks whether the symbol at the top of the stack is a terminal. So, if the symbol at the top of the stack is a terminal, it is handled in this block. Or otherwise, if the symbol at the top of the stack is not a terminal, that means it is a non-terminal, the algorithm handles that scenario using this block of the code. So first we see what happens if the top of the symbol at the top of the stack is a terminal. If the symbol at the top of the stack is a terminal, it checks whether it matches the current input symbol. So this is the symbol at the top of the stack, symbol at the top of the stack, and it matches input symbol, input string, head of the input string. That means the first symbol at the input string. It checks whether it matches the current input symbol. If there is a match, so if the symbol at the top of the stack is a terminal, it matches it with the head of the input, and if they are they are same, then these two lines are going to execute. What are those lines indicate is if there is a match, the input symbol is consumed by moving to the next symbol and the terminal symbol is popped from the stack. First, the input symbol is consumed by moving to the next symbol. That is being done using the tail function. Tail input. It consumes the first input symbol and go to the next symbol. And then the terminal symbol is popped from the stack. So that is the case where top of the symbol at the top of the stack is matched with the head of the input. If it is not, then error is raised, indicating a mismatch between the expected and the actual symbol. Next, we go to the second scenario where the symbol at the top of this stack is a non-terminal. So, if the symbol at the top of this stack is a non-terminal, the OPF, omniscient parsing function, is consulted to determine the appropriate production rule. They call the omniscient parsing function and get the production rule based on the top of the stack symbol and the current input symbol. The selected production rule's right hand side is pushed onto the stack, replacing the non-terminal symbol. That is done in this line. What it does is the selected production rules, that means P's right hand side is pushed onto the stack, replacing the non-terminal symbol. So, by repeatedly applying these steps, the algorithm progresses through the parsing process, matching symbols and replacing non-terminals until the stack is empty, indicating a success pass. Or, as I said before, an error occurs indicating an invalid input string for a given grammar.